In this chapter, we're going to talk about piecewise function. So what's a piecewise function? Piecewise function is a function which more than one formula is used to define the output. Anyway, don't worry about that. I'm going to give you an example. So for example, when you go to some movie or some administration, they will tell you that, hey, so the ticket price is going to be different, such as, let's say when you go to see a movie, I don't know exactly, I'm going to make up some number. If you are a student, you pay $7. If you are a senior, you're going to pay $6. If you're 18 to 64, that means adults, not a student or senior, you're going to pay the full price, which is $15. So this is what we call piecewise function in application. That means determined by your age. The ticket of the price of the ticket is determined by your age or your social status. Okay, so now look at this function. Sketch the graph of each function. So when you look at when x less than -4, when x less than -4, which is this part, the left part, when x equals to -8, -6, -4, as long as it's less than -4, the output is going to equal to x. So now let's find 2 points. We know that this is going to be a linear function. When x equals to -4, we can choose that one. Let's say when x equals to -5, -5 is less than -4, so we can use the first function. So fx hs is equal to -5. When x equals to -6, fx equal to -6, because h of x equals to x. Okay. So now let's plot these points. So I have 5, -5, in here, 6, -6. So this is going to be a 9. But this 9, when you reach the boundary, the borderline, which is x equals to -4, this is no equal sign, right? So that means this is going to be an empty dot. Okay, so for the second range is when x, I'm going to use different color. When x is between -4 to -2, so that means from this area, -4 to +2. I'm sorry, not -2, +2. Can you able to see it? Oh, let me change to the green. Okay, so hs is equal to 5. What's that mean? That means when x equals to -4, y equals to 5. When x equals to 0, which is 0 is between -4 and +2, fx equals to 5. Even when x equals to 2, y equals to 5. So this is going to be what? A horizontal line. So it would be here. So we need to be careful about the edge. So since what x can equal to 4, so this is going to be a solid dot on the left end. But on the right end, since it's not equal to 2, it's just less than 2. So that means this has to be a circle. Okay, so the next one, I'm going to use a blue pen. So the blue pen is what? When x is greater than 2. So that means this area. From 2, not negative, from 2 to +infinity. Okay, so we have when x equals to 2, +2, fx equals to what? -x plus 2, which is 0. And then when x equals to 3, -3 plus 2, which is -1. So this is a linear function. We just need 2 points. We have 2, 0, which is here. They can equal to that. So that's why it's a solid dot. And 3, -1 here. Connect these 2 points. So this is the graph. Total has 3 parts determined by different range. Okay, now Let me give you another example. So the first part is when x less than -4. I'm going to use the blue one. So -4 is the left part. When it less than -4, the function equals to -4, which is a straight horizontal line. Can it equal to -4? No. So that means on the edge, this is going to be a empty circle. So, and then for the middle part is -4 to 0. So that means from -4 to 0, I'm going to use a blue line. Between this period, we have x at minus x minus 4. So let's say if this is equal to -4, then the function is equal to -x of -4, which is +4. And then this is 0. And then I have -3, negative of -3 minus 4, we have -1. So with 4, 0, they can equal to that. So it's a solid dot to -3, -1. -3, -1 is in here. So it's going to be like that. But when touch the borderline, which is x equals to 0, it's not equal, right? So that means we need to have an empty circle on here. Solid dot on the left, and then empty circle on the right. Okay, the last part, I am going to use a pink one. The pink one is when x greater than 0, the function is equal to -3, which means equals to solid dot like that. So this is a piecewise function. You just need to separate into 3 parts and draw a different function. Draw a different graph. Okay, so now they say a museum charged $5 per person for guided tour with a group of 1 to 9 people, or a fixed 50 fee for a group of 10 or more people. Write a function related to the number of people and to the cost. Okay, so from the cost and the people n, so they have 2 parts, right? When the group is between 0 to 9, so that means when n is less than 9 or greater or equals to 1, they charge what? $5 per person. So we don't know how many people. So it should be, the total cost should be 5 times n. Okay, so, or a fixed cost, which is $50 if a group of 10 or more people. That means when n is greater than or equals to 10, the cost is going to be $50. So this is the piecewise function. Okay, so a cell phone company uses the function below to determine the cost in dollars for the gigabyte of data transfer. So when the gigabyte between 0 to 2, it costs $25. And then if you use more than 2 gigabytes, the charge is going to be $25 plus 10 times whatever extra times 10, right? So find the cost using 1.5 gigabyte. Well, 1.5 gigabyte is what? 1.5 gigabyte is in between 0 to 2. So the cost of using 1.5 gigabyte is $25. And then the cost of 4 gigabyte. 4 gigabyte is what? Greater than 2. So that means we need to use the second function. So we have 25 at 10 times 4 minus 2 equals to 20, which is $14.5. So that means if you use 4 gigabyte of data, you're going to be charged $14.5. So absolute value. So don't worry about the previous letters. Just look at the last one. Suppose a resistor rated 680 ohms and plus or minus 5% use the absolute value function to express the range of possible value of the actual resistance. So what would be the actual resistance? So let's say it has to be what, within positive or negative 5%, right? Otherwise, you will be over it, right? So let's say let X be the actual resistance of the resistor. Okay, so we want it to be controlled within 5%. So 5% is equals to what? That means 618 times 5% equals to 13.4. In this specific example, we want the margin of error is in, you can have margin of error would be 13.4 ohms. Okay, so how can we express that? That means when the actual resistance subtract the standard, which is what we want to get, 618, the absolute value of that, you could be less than or more than 5%, which is 13.4 ohms. We want it to be within the range, within 5% of what they require. Okay, so student who scored within 20 points of 80 will be passed the test. Write the distance from 80 using the absolute value notation. So let's say let students score equals to X. You want X minus 18 is within 20 points, right? So that means X minus 18 has to be less than or equals to 20. That means X can be what? That means X can be 100 because 100 minus 18 is positive 20. It's still within the 20 points range. Or X can be 99, 98, even 80. When X equals to 18, 18 minus 18 is within 20 point differences. But even lower than 18, such as 78. 78 minus 18, which is negative 2, still within 20. So that means we need to use the absolute value. We want the value positive or negative is less than 20. We want X minus 80 is going to either greater than 20, in between positive 20 and the negative 20. So that means they can go to from 100 to 60, because if the student scores 60, 60 minus 18 is equals to negative 20, still within the 20 points range. Okay, so graph a absolute value function. So first of all, absolute value, the basic absolute value, which is fx equals to absolute value of x. The graph is going to look like a V, because you think about it, when x equals to 1, fx equals to 1, right? When x equals to 2, fx equals to 2. So that means this way is going to look like a linear function with 45 degrees. And then when x equals to negative 1, fx equals to what? Since it's absolute value of negative 1, fx equals to 1, which means the point is here. When x equals to negative 2, fx is equals to positive 2. So the graph is towards that side. Also 45 degrees to the x-axis. So it's look like a V. Okay, and we know that, hey, this is going to be symmetric. Okay, so now they want you to graph each function. As long as we can graph one side, we know that this is going to be symmetric. We can mirror the other side, right? So now let's just graph one side. So how can we find the middle point? So the middle point is when the absolute value is equal to 0. So now take a look. X minus 4, how can you net x minus 4 equal to 0? So when x equals to 4, x minus 4 going to equal to 0, right? So the first point we can find is when x equals to 4, y equals to what? 4 minus 4, 0. 3 times 0, 0. Then y is equal to negative 2. So we find one point. 4, negative 2. 4, negative 2 here. And we can find another point. When x equals to 5, we have the absolute value is 5 minus 4, 1. 3 times 1 is 3 minus 2, which is 1. 5 and 1 in here. So the graph is like that. So since this one is equal to 0, that means this is going to be the symmetric. So on the other side, the graph is going to be symmetric. So that means you will have a point in here, mirrored in this line, okay? So you will have the graph look like that. Okay, second one. Again, let's find the central line. Okay, s plus 1, how can this equal to 0? When x equals to negative 1, right? When x equals to negative 1, so with y equals to what? 2 times 0 equals to 0 minus 2, negative 2. We have negative 1, negative 2. Negative 1, negative 2. Okay, now we need to find another point. When x equals to 0, we have 0 plus 1, 1, 2 times 1, 2. 2 minus 2, 0. So 0, 0. So we'll be here. So the line is going to look like this one. And then since it's symmetric over this point, so we can find another point in here and connect them. So this is the graph. Okay, number 9 will be what? We want this part equals to 0. That means we want x equals to 4. When x equals to 4, y equals to positive 2. So I have a 4, 2. And now we need to find another point. Let's say when x equals to 0, we have a 0 minus 4, which is, oh, maybe that's too big. Let's find something smaller. That's outside of the range. Let's do 2. When x equals to 2, we have a negative 2. Negative 2 times negative 3. Oh, no. Negative 2, absolute value of negative 2 is equals to positive 2. Negative 3 times positive 2 is negative 6. Plus 2, which is negative 4. We have a 2, negative 4 in here. So we know that this line is going to be the symmetric one. So that means the other side would be at this point. So now we connect them. This is the graph. Again, on your homework, please show your step. Which point did you find? Okay, last one. We have x equals to negative 3. And then we have y equals to negative 2. The second point I'm going to find is when x equals to negative 2. When x equals to negative 2, we have negative 2 plus 3, we have 1, and then negative 5. So we have negative 3, negative 2. Here's the symmetric line. And then negative 2, negative 5 in here. And this 2 is going to be symmetric. So here's the graph. Not hard, right? Okay. So make sure that you will do all the practice. See you next time.